Hello, hi, good morning. So yesterday we did few questions of chapter matrices. Today we'll just continue with that only. I hope you have revised. The main thing is practice. Though it is the initial days or initial, concepts only. Um, Gradually and slowly we'll move to some difficult level of questions also. But of course, before that, you should know the concept and how to apply those concepts. That's why I was doing those questions. And it is a part of your material as well. So we'll continue today. Let me write few questions. Before that, I just want to tell you one more thing that we have already done types of matrices, skew symmetric matrix, symmetric matrices. These kind of things we have already done. Types of matrices means row matrix, column matrix, and all those things on top. We have already done transpose of a matrix. Yesterday we did few questions on that transpose of matrix. So today I'll just continue the same pattern, the questions only. Because the more questions you will do, anyhow you will be able to do the theory part. So before that, yesterday I told you two properties of two rules of trace of many matrix. Properties or rules, I would say. Properties related to trace of a matrix. First is, yesterday I told you, trace of k times of A. That means any scalar is there if it is getting multiplied with any matrix. So it is nothing but k times of trace of A. Second is trace of A plus B is nothing but trace of A plus trace of B. Okay. Trace of AB, trace of AB equals to trace of BA. This will be applicable during the question. If any question is there related to this, then you can apply the concept. Trace of any identity matrix of order n will always be n. Reason is very simple. Suppose if any matrix is there, suppose I'm taking 2 cross 2 matrix. So 2 cross, okay, I'll take 2 cross 2 first. First I'm taking 2 cross 2 matrix. So trace is nothing but what? Sum of the diagonal elements. 1 plus 1 is nothing but 2. Order was also 2, trace is also 2. If I'll talk about 3 cross 3 matrix, order is also 3 and trace is also 3. 1 plus 1 plus 1, which is nothing but 3. Trace is nothing but what? Sum of diagonal elements. Diagonal elements are nothing but 1, 1, 1. So whenever there is a nth order identity matrix, so trace will be n only, because all the diagonal elements will be 1, 1, 1, 1, 1. And if you will add 1 n times, it will come out to be n. Trace of AB is nothing but trace of A into trace of B as well. Okay. And of course, if it is ABC, BCA and CAB. All the traces will be equal. Note it quickly, then we'll proceed to the other properties once, and then we'll do that questions today as well. The questions which we left yesterday, today I'll do those questions as well. I'll take the properties later. One question I'm giving till then. If any matrix A is given 8, 0, if A is 8, 0, 4 minus 2, 3, 6. A matrix is given and B matrix is 2 minus 2, 4, 2 minus 5, 1. 4, 2 minus 5 and 1. If this is given to you, you have to find the matrix X. You have to find matrix X such that one condition is there, 2A plus 3X equals to 5B. This condition he is asking. 2X 5 plus, sorry, 2A plus 3X equals to 5B. Okay. Now what we have to do here is, B we already know, A we already know. Okay. X we have to find. So X we will keep on the left side. Other things we will take it on the right side. So 3X equals to 5B. This 2A is plus here. On the right side it will become minus. This 3 is multiplied here. On the right side it will become divide. So now 5B. 5B means what? 5 will be multiplied with all the elements here. So that I'll do now. 5 2s are 10. 5 minus 2s are minus 10. 5 4s are 20. 5 2s are 10. 5 5s are 25. 5 1s are 5. Okay. Minus of 2 times of A. Whatever the matrix is there, we'll multiply it with 2. 8 2s are 16. 2 zeros, 2 4s are 2 2s, 2 3s, 2 6 are 12. Okay. So simplify it. Now order is 3 rows, 2 columns. 3 rows, 2 columns. Order is same. Corresponding elements we will subtract. 10 minus 16. It will come out to be minus 6. Minus 10 minus 0 is minus 10 only. 20 minus 8 is 12. 10 minus minus, it will become plus. So 10 plus 4 is 14. Minus 25 minus 6, it will become minus 31. 5 minus 12 is nothing but minus 7. So this is your matrix X. Now what we have to do is, whatever the numbers are getting divided by 3 completely, we'll divide. Which are not completely divisible, that's okay. We can leave it till that point only. So minus 6, when you will divide it with 3, it will come out to be minus 2. Minus 10 by 3, 12. It will be divisible by 3, so it will come out to be 4. 14 is not divisible, 14 by 3. 31 is not divisible, minus 31 by 7 is also not divisible. So this is the required matrix X, and this is the answer. So whichsoever option is getting correct, that you can tick. Um, after like today it's Friday. Monday I will start with the J mains questions as well. Though these are also your material questions only I am doing, but a bit level up questions I'll start now. A bit, not extremes, because side by side we have to do so many questions. Practice, practice, practice. Only practice you have to do every time. Like in maths, we cannot say if we are doing these many questions, it is enough. The word enough is not there. No point. As many as questions you guys can do, that would be better. All right. Now, few more things. If I'll say multiplication, related to multiplication, I'm saying now. Now, during multiplication, I told you one thing, that it is not necessary that every time AB and BA are equal. So if I'll talk about the commutativity, AB is not equals to BA. But in rare cases, it can be equal. Very rarely it happens. All right. So, but if I talk about any note, this note I am giving, three matrices, suppose three matrices are there, A, B, C. Can I say this is associativity? You must have done in your 8th class, no? All the properties when rational numbers were there and those kind of things were there. So that time you must have seen the word commutativity, commutative, associative. So this is associative. That means just the bracket shift. Okay. AB into C is equals to A into BC. Alright, now I'll take any question, then you will be able to understand more. Not only on this, just randomly we can take any. Or distributive law also you must have heard. A into B plus C is nothing but AB plus AC. This was a distributive law, just we were doing with the any number, but here I am doing it with the matrix. All are matrices. A, B and C. All are matrices. If any matrix is there, if I'll multiply with identity matrix, of course this order has to be, match. Equals to I of A equals to nothing but A. Either we write A into I or we write I into A. It will come out to be A only. As I said, it is not necessary. So write these 4 notes. Now I am taking one question after this. Next question. If A is any matrix, either it is symmetric or skew symmetric. Both the ways we have to check. When it is symmetric matrix also, then what will happen? If it is skew symmetric matrix, then what will happen? I am writing symmetric matrix rule. Symmetric matrix means what? Symmetric means A transpose should be equals to original matrix A only. And skew symmetric means A transpose is nothing but negative of original matrix. Okay. So if A is any matrix, we have to show that depending upon this only, B A B dash, what will happen to this? Dash means transpose. And transpose means what? So I'm revising the concept side by side. Transpose means row will become columns, respective column. So this is transpose only. Now what will happen to this? Try it once. If a, let the first case, if we'll say case 1, when A is symmetric. When A is symmetric means what? A transpose is nothing but equals to A. Now what will happen to this matrix? Is it coming out to be symmetric or is it coming out to be skew symmetric? So whenever we have to see the symmetric and skew symmetric, what we have to do is we have to take the transpose. Transpose means what I'm saying. Whatever the matrix, if we have to know its nature, what we'll do, we'll start with its transpose. Okay. And properties of transpose, when I did, I must have told you one thing. A, B transpose. Whenever two matrices are multiplied and when we are taking its transpose, so it will come out to be B transpose into A transpose. That means AB transpose is nothing but B. It is not equals to A transpose into B transpose. No. It will be equals to, that means second matrix will come at the first place, first matrix will come at the second place. That kind of manipulation will happen. Okay, I'll write that question once more. So the question is, if A is All right. So if A is symmetric matrix, symmetric matrix means A transpose is nothing but A. We have to see the nature of B. We have to see the nature of B A B dash. So we'll start with its transpose. Transpose means just now I told you the property that AB transpose is nothing but B transpose into A transpose. So I'll apply that concept here. That means third matrix will come in front. Its transpose I'm talking about. Second matrix will be at second place only, and like order will be interchanged. Okay. And one more property, any matrix transpose, and again transpose if you will take, it will come out to be the original matrix. Suppose I am talking about any matrix 1 2 3 4. Take its this is suppose original matrix B. Take its transpose. B transpose is nothing but first row will become first column, second row will become second column. Okay. Talk about its again transpose. Transpose ka transpose I am talking about. So again what it will become? First row will become first column, second row will become second column. Okay, so this is nothing but original matrix B. It is getting matched with B only. So same ways I'll write it here. B transpose transpose is B, A transpose as it is, B transpose as it is. Alright. So now what it is coming? Anyone? But we have to use this concept also. B, A transpose is nothing but A only and B dash. See, we started with its transpose and we are coming back to again the original matrix. So this is nothing but B, A, B dash is also symmetric matrix. I'll tell you once more what I'm saying. See, it is given to us as A is symmetric matrix. Okay, symmetric matrix means A transpose equals to A. We have to see that whether this is symmetric or skew symmetric. So we'll start with its transpose. Transpose has its property, order will reverse. B dash, full transpose, A transpose, and then B transpose. Transpose will come out to be the original matrix, A transpose as it is, B transpose as it is. A transpose equals to A only, which is given to us. So some transpose is coming out to be equals to some matrix. So that means original matrix is nothing but symmetric. Next, if I'll do one more. Suppose A dash is skew symmetric, not A dash, A only. Suppose A is skew symmetric matrix. Skew symmetric means what? A dash equals to minus of A. Okay. Now we have to see the nature of B A B dash. Again we have to see its nature. It will come out to be skew symmetric only. Now see, start with its transpose. As I said, we will change the order A dash and B dash. First of this, then of this, then of this. Okay. Transpose is nothing but original matrix. A dash is nothing but minus of A and B dash is B dash only. We know this minus will come in front. Minus of B A B dash. Now see, original matrix transpose is coming out to be minus of original matrix. Okay, so it will come out to be skew symmetric. It is getting flecked with my dupatta, so that is why every time that another screen is coming. Note it. This is a question. Next part. You have to be quick while noting it down. Can't waste more time. Next question. Just one thing I am proving, that YA AB transpose is equals to B transpose into A transpose. Okay, I'll take any matrix and then we'll do with that. AB transpose is coming out to be B transpose into A transpose. This is a note you can say, or this is a result we are doing. It is required some or the other. That's why I'm taking AB transpose is nothing but B transpose into A transpose. Suppose I'm taking any matrix 1, 2, 3, 4. B matrix I'm taking as 1, 3, 0. Suppose any. It is not necessary that these numbers has to be same. It is not necessary. I can go with the 4 also. In your books they have given 4, so I'm taking 4 only. Okay, you can take any matrix. Check it with a 3 cross 3, but it is easy to check with a 2 cross 2. That is why I'm taking 2. Alright. So now AB. First, before finding its transpose, we have to find a product. Product means what? Again, we are revising the concept of multiplication here. First row will be multiplied with first column. Okay. So 1 into 1 is 1. 2 into 0 is 0. Now first row will be multiplied with second column. So 1 into 3 is 3. 2 4s are 8. Next, second row will be multiplied with first column. That means 3 into 1 is 3. 4 zeros are 0. Now second row will be multiplied with second column. 3 3s are 9. 4 4s are 16. Add them. What it will become? 1 plus 0 1. 3 plus 8 11. 3 plus 0 3. It will become 25. This is nothing but AB only. But now we have to talk about its transpose. Transpose means first row will become first column. Second row will become second column. Okay, this is my LHS. Now we'll talk about RHS. RHS means first we have to see B transpose. B transpose is nothing but first row will become first column, second row will become second column. Column means vertical, row means horizontal. Similarly, we have to see A transpose. A transpose, first row will become first column, second row will become second column. I hope I am clear till here. Now, what is the operation they are asking? Multiplication. So, multiply them. B transpose, A transpose. Okay. Now, as I said, first row will be multiplied with first column. Okay. So 1 ones are 1, 0 into 2 is 0. Now first row will be multiplied with second column. 1 into 3, 3 plus 4 into 0 is 0. Now second row, first column, 3 into 1, 3, 4 twos are 8. Second row, second column, 3 threes are 9, 4 fours are 16. So what it is? Add them. 1 plus 0, 1, 3, 11 and 25. LHS equals to R. My result is true. Note it quickly and then I'll start with another question. These are the things which we are going to use it now. Now onwards, like we will use all these results. We don't have to prove this thing. Just to tell you in detail, I am telling all these things. You should know because it can be applicable anywhere. And then we'll do what I am thinking is by tomorrow. I don't think so by tomorrow it will be possible. Monday or Tuesday, 1 or 2 days I'll take more for the concept part. And then we'll move to the previous year questions and your material questions. Okay. Material questions are there. So we'll do those questions. But previous year questions also we'll do. Okay. So much things are there. Ample of things are there actually. One question I'm taking now. If A matrix is, if matrix A is 3 root 3, actually this is a part of the concept. No, we cannot skip these questions, though it is easy, but we can't skip anything. 4 to 0. Book question again. 2 1 2. I'm doing it from your material. 2 1 2. 1 2 4. 2 minus 1 2. 1 2 4. Now which thing we have to prove here is A transpose transpose will come out to be A. Yes, we have already done. It will come out. I know it will come out. Try it quickly. We have already done this kind of question. See, first what you will do? First you will find A transpose and then the matrix which you have obtained, again find its transpose. It will match with the original matrix. We'll do, but first you will try. It's easy. Hardly it will take few seconds. First I'm talking about A transpose. A transpose is nothing but first row will become first column. Second row will become second column. Then again we have to talk about its transpose. So first row will become first column, second row will become second column, and third row will become third column. So this is nothing but original matrix proved. This part is proved. Second part for this only, A plus B transpose. Second part is A plus B transpose will be equals to A transpose plus B transpose. Here we don't have to write B transpose plus A transpose. No need to write a plus is commutative, no? Either you write 2 plus 3 or you write 3 plus 2. Though it is for multiplication also, but that was the numbers. Oh, no. So for the plus, no need to write B transpose plus A transpose, because commutative, like addition of the matrices is commutative. Multiplication of matrices is not commutative. Okay. So A transpose A plus B. First I'm finding LHS. A plus B. A plus B is, add the two matrices. 3 plus 2 is 5. Root 3 minus 1. 2 minus 2 plus 2 is 4. 4 plus 1 is 5. 2 plus 2 is 4. 0 plus 4 is 4. Now we have to talk about its transpose. Okay, we'll do the transpose. First row will become first column. Second row will become second column. Talk about A transpose. Now come to RHS. A transpose. A transpose, we already have 3, 4, root 3, 2, 2, 0. B transpose, we have B transpose 2 minus 1, 2, 1, 2 and 4. Now add them. A transpose plus B transpose. Add the respective or corresponding numbers. 3 plus 2, 5, 4 plus 1, 5, 3, root 3 minus 1, 2 plus 2, 4, 2 plus 2, 4, 0 plus 4, 4. LHS equals to RHS. These are the results only which we have to use directly. We don't have to prove it every time, just it is a part of your material. So I'm doing these questions. When we'll be done with the concept, then we'll proceed to the bigger questions. Another part is also there. Third part, note it quickly. Third part is also there. That also I'll do. Today I'll tell you one more concept, the interesting concept that I'll tell you. After one part only, I'll tell you. Quickly complete. Next, he's saying third part we have to prove as K into B whole transpose is nothing but K into B transpose. Of course, this will happen. Okay. So we'll see the B. B is 2 minus 1, 2. 2 minus 1, 2. 1 to 4. 1 to 4. I have to write K here, not 2. Okay, K of B full transpose I have to apply. Now K into B, first multiply 2 into K is 2K, K into 1 is K, 2 into K is 2K, K, 2K, 4K, full transpose. Transpose means nothing but first row will become first column, second row will become second column, second row will become second column. This is my LHS. Now talk about RHS. RHS first he is saying we have to do the B transpose. Do B transpose. B transpose is nothing but first row will become first column, second row will become second column. Now multiply it with K. So it will become 2K, 2 minus K, 2K, 2K, 4K. So can you see these two matrices are same? LHS equals to RH. Okay. That you guys can see the video once again. And whatever the notes are incomplete, you can complete your notes because anyhow you will be needing all these things later on also. So notes should be complete. Weekend is near, so then you can complete your notes. If I have not given ample time to note it down because anyhow it is recorded now, so you guys can note it later on also. Next, I'm telling you the new concept, that is elementary row or column transformation. That is an important concept again. Now, what is the concept? Elementary row or column transformation. Now, what does it mean? See if any matrix is there. Any matrix is there. A11, A12, A1n. A1n, A21, A22, A2n, AN or M, AM2, AMN. Okay, these things are there. Any matrix is there. Now, any row, any ith row can be interchanged with any jth row. If you are applying with the column, ith column, then jth column should be there. These two, like either you can apply to the row or you can apply to the column. Okay, don't say this that R1 is changed to column 1. No, you should not say like that. That I am saying R1 I am changing to R2. I can change. Interchange. I'll give you the example also on this basis. Now, second thing what I can do is, this is the first operation. Second operation what I can do is, or second transformation what I can do is, any ith row I can multiply with any constant also. Again, I'll give you the example. Third operation or third transformation what I can do is, This means interchanges. Okay. And third transformation is nothing but Ri is changed to Ri plus k times of Rj. Okay. Now what does it mean? Suppose I am talking about R1. R1 I am changing. I am adding 2 times of R2. That I'll tell you now. First note it down, then I'll give you the example. It will be easy. It will be more easy to understand. Suppose I'm giving you, first note it down, then 1, 2, 3, 3, 3, 6, 9. Suppose anything like this is there. It is not necessary that it should be the proper multiple. No, it is not necessary. I'll take the different one. 7 and 10. Anything. Yes, anything else. Random numbers. Now what I am trying to say, this matrix is equivalent or can be same as, or I can rewrite this matrix as, I can interchange. Now R1 I am interchanging with R2. So R2 will come up because R1 is changing with the R2. R2 will become R1. R1 will become R2. This means this. R1 is changing to R2. R2 is changing to R1. So 1, 2, 3. Okay. Second operation, what I said, this is the second operation I am applying. Any row I can multiply with any constant also. Suppose I am applying this R2, I am multiplying with -7 of R2. Now why these transformations will happen and how we'll get to know with which number we have to multiply? One question is there, inverse. Whenever we have to find the inverse of any matrix, that time these concepts will be applicable. When I'll do the question, I'll tell you properly that time how we'll get the idea with which number we have to multiply, when we have to change, with which row we have to change, everything I'll tell you that time only when I'll do that question. Today though I don't think so I'll get enough time, but tomorrow I'll take this question only. Find the inverse using elementary transformations. So then I'll tell you properly. So now what I said, R2 I am multiplying with -7. R2 is what? And we have to do it with the original matrix. Okay, so whatever I'm doing, I'm doing with the original matrix right now. So 1, 2, 3 as it is. Row 1 is as it is. Row 2 I am multiplying with -7. -3, -7 threes are -21, -49, and 10 minus 7 is -70. So that means all the three numbers will be multiplied with -7. And which three numbers? Only of the row 2 I am changing. Okay. Now suppose that matrix I am taking and third elementary operation I am applying. This operation I want to apply. Now see what I am doing is R1 I will change, with which I will change R1, and if I subtract, if I want to subtract or add only 2 times of R2, suppose, or what I can do is one more operation I can apply. Suppose they have given me in the task, they want this element to be 0. Now how this element can be 0? If I multiply these numbers with 3 and if I subtract, it will become 0. Now what I'm saying, I'll tell you. See, R2 I'm changing now because in the question maybe they have given make this element as 0. That means this is R2 ka element. So R2 I have to change. R2 minus of 3 times of R1. Why I have written 3 times of R1? Because 1 if I'll multiply with 3, it will become 3. 3 minus 3 will become 0. Okay, from that only I got the idea. So multiply it with 3. What it will become? 3, 6, 9. Okay, don't write 3, 6, 9. Write 1, 2, 3 only. But when we will subtract here, 3 minus 3, it will become 7 minus 6. It will, what does it mean? First, we have to write the element of R2. Then we have to write 3 times of element of R1. Okay, that's what I'm doing. 10, 3, 3s are 9. That's what I'm doing. Now what it will become? 1, 2, 3, 0, 1. Now suppose if I have to make this as 0, what I will do? R1 tends to, if I multiply this with 2, what it will become? Subtract it. So if you will multiply it 0 with 2, it will become 0 only, and this will remain same. So 1 minus 0, 2 minus 2 into 1, 3 minus 2 into 1. 0, 1, 1 as it is. So now what it will become? 1, 0, 1, 0, 1. Suppose if I have to make this element 0 now, what I will do? I will subtract all the numbers here. That you leave. No, just to make you understand, I have taken this. Again, tomorrow I'll take the question on this basis only. I know this is little bit confusing because the end of the time. So I just gave you the introduction of the concept. This is not the end of the concept. I'll do the questions tomorrow and I'll make you more understand tomorrow on this. Okay. So I hope today's class is clear to everyone. Just view the class once again. Any doubt, you can resolve it. Okay. Bye guys. Hope you have understood everything. Tomorrow we'll meet with the elementary